Hi dears, observe this question, very interesting. Before going to that question, better to log in our website, okay, for more updates, okay, right. Of course, easy question. The question is, what are the eigenvalues of matrix? Simple. It's not asking vectors, eigenvalues only. It's not asking eigenvectors. It's asking only eigenvalues. Very simple, right? Of course, we'll have two procedures. 3 by 3 matrix. That's why we'll have two procedures. First one is what? Come on, we need to find det of a minus lambda I should be equated to 0. Then only we can get lambda value. Lambda value. Why? Because whenever we 3 by 3 matrix, 3 roots will be there, right? Cubic equation. 3 roots will be there. Lambda will have 3 values. That's it. We need to identify lambda. That's it. What is I? I means what? Identity matrix. A means the given value. So this is procedure 1. Okay. After equating to 0, we can get more values. According to that, you can decide, right? Simple concept. We'll have one more way also, very interesting. What is that way? Second method. Second method is, already we have given introduction also. Actually, what are the eigenvalues actually? What is the scientific priority for that one? We'll have introduction class. Don't miss eigenvalues introduction part. Okay? Don't confuse me. Very simple concepts. Okay, but I can go for one more way. Of course, we'll get cubic equation for sure. If I solve. If you go for det value, you can get cubic values for sure. Yes or no? According to that second method, lambda cube will be there for sure. Positive value first minus lambda square will be there. Okay, but we need to find here. S1, right? After that place, lambda will be there. We need to find S2. After that, last but not least, det A is equal to 0. This can be second method. What is our first method? A minus lambda into identity matrix determinant value should be equated to 0, or else we can get the same value for like according to this procedure. Then what about S1 here? Very simple. S1 is nothing but sum of principal diagonal elements. Sum of principal diagonal elements are nothing but 2 plus 4 plus 2, right? Sum of, be careful, sum of principal diagonal elements. Sum of principal diagonal elements. Okay, fine. Then what about sum 2? I mean, here we need to go for, but observe it now. Minus plus minus values will be there for sure. Det means already we have idea about det. That is another issue. But what about S2? S2 is nothing but very simple concept. Don't confuse. S2 is nothing but we need to find the minor values of principal diagonal elements. These are the principal diagonal elements. Yes or no? So if I choose minor elements for this one, I want minor elements. Close to 2 closed. What about remaining values? 2. Entire column and row should be eliminated. Will have remaining values 4, 2, 1, 1, right? AD minus BC should be taken. That is called minor. So again, what about second minor? I need to go for principal diagonal elements only. Close 4, eliminate column and row. Column and row. 2, 1, 1, 2 will be there. AD minus BC. In that case, according to the procedure, we need to find S2 value. S2 value is nothing but the sum of minors of principal diagonal elements only. Not all. Principal diagonal elements, minors only. Right, then what about A? Det A is nothing but determinant value. So this is the basic approach of the second procedure. But according to this situation, the first one is very easy, right? For your comfort only. First one is very easy. I think so. So that's why better to go for this procedure. So we have given the introduction part of eigenvalues and as well as vectors, eigenvectors also. That's why don't confuse. I think you got the idea, right? No problem at all. Now we can go for a solution. How to solve this equation, right? Don't confuse me. Okay. First of all, what is the first matrix? A. What is that? Okay, this can be A, right? Directly I can take it is A. So we need to find delta I. Delta I means what? So delta means what? Lambda, not delta, lambda. Lambda I. Lambda I means directly you can go for determinant of these values. That's why. Come on. Directly I can go for the steps. Okay, for your comfort. So det compulsory det for this question. Det of, observe clearly. 2 lambda into I means I is nothing but identity matrix, right? What is I value? I is nothing but, for your comfort, don't confuse all of you. 1 0 0 0 1 0 0 0 1. So lambda into 1, remaining all are zeros, right? Directly we can subtract it, right? So lambda into I means what? Lambda into 1. Lambda into 1, that should be subtracted from 2. 2 minus lambda into 1. That is first element for this. Okay, fine. Then what about second one? Second one can be directly we can say lambda into 0 will be 0 only, that's why 1 will be common. Only principal diagonal elements will be affected, remaining will be same. That's the main issue, right? That's why directly connect 1 1. Then what about 4? It can be again 1. 4 means 4 minus lambda. 4 minus lambda, that's it. 2 minus lambda in the same way, 4 minus lambda in the same way. What about next one? It will be same story, same concept, directly 2 minus lambda. So we need to find the determinant value that should be equated to 0, right? After going for determinant value, you can get equations, right? So the equation will be in the form of cubic only. If you observe this one, it will be also same story, right? Okay, don't confuse. Okay, what is the next step? Next step can be, come on. So first element will be 2 minus lambda into, right? 2 minus lambda into, we are going to find that value. Okay, so eliminate this row and column. 4 minus delta into AD, okay, don't confuse now, AD minus BC means what? 1, right? After that we can go for 1. 1 should be in negative mode, minus 1 into plus 1 minus 1 plus 1, like that. Minus 1 into determinant value, don't confuse, 3 by 3 matrix. Minus 1, eliminate column and row. 1 into 2 minus alpha, 1 into 1, that's it. 2 minus alpha means lambda, whatever. 1 into 1, 1. Yes, then what about third one? It can be 1 into eliminate row and column. 1 into 1, 1 minus 4 minus, come on, 1 into, this 1 into, don't confuse, 1 into eliminate column and row, 1 into 1, 1. 1 minus of 4 plus lambda will be there. That should be equated to 0. After simplifying, we can get cubic equation for so like this. After getting cubic equation, actually we need to solve the equation, right? After getting the values, you can choose from the options. It may be 1, 2, 5. According to my perception, option A should be our answer. Okay, if you solve this one, you can get the answer. Why? Because 2 minus lambda into 4 minus lambda is there. Again, we need to simplify it. Lambda into lambda and lambda will be lambda cube. And you will have lambda square values and as well as lambda values, right? In that case, it will be difficult. That's why this is a procedure actually. This is a procedure. Okay, I think you got the idea on this story, right? Method 1, method 2. Method 1 will be easy. In your calc, you can get the solutions for sure. Okay, it is not a big story, right? Whatever, I think you got the idea, right? This is a basic concept. I hope you are getting good command. This is very, of course, huge story, right? Okay, my perception is what? Better to use your calc. After getting cubic equation, we need to choose options. What is that option? Equations option in your scientific calc. After choosing equation options, you will get cubic option, right? In that cubic action, you need to substitute quotient of cubes and squares and as well as power 1 coefficient value and as well as constant. Then you can get the solutions for sure. After getting the solutions, according to options, you can decide it, right? That is a basic concept, right? You will have scientific calc, happily you can find the answer. This is a basic story here. But without calc, without this general procedure, how can you get the answer directly? That's my perception. Don't confuse. Our wing is very interesting, don't confuse. After solving the equation, you can get 3 roots, right? Yes or no? Lambda values can be 3. Let's assume that those values are lambda 1, lambda 2, lambda 3. Okay? Of course, we will have options. There is another issue. The relation between the roots and as well as the given matrix is very simple, don't confuse. Observe clearly. Let's assume that the roots are lambda 1, lambda 2, lambda 3. Sum of the roots, very interesting. Lambda 1, don't confuse. Lambda 1 plus lambda 2 plus lambda 3 is equal to the sum of the principal diagonal elements of a given matrix. Come again. Sum of lambda 1 plus, sum of the roots of a cubic equation is equal to the sum of the principal diagonal elements of a given matrix. Nothing is there. Find the sum here. 2 plus 4 plus 2 will be 8, right? Yes. Sum of the principal diagonal elements will be 8. So I need to get, this is first condition. So we need to verify it, that's it. Lambda 1 plus lambda 2 plus lambda 3 will be 8. What are these? The given roots according to options. The first option will be 1 plus 2 plus 5. Yes, it is matching. Lambda 1 can be 1. 1 plus 2 plus 5 can be 8. Yes, it is matching. Maybe there is a chance to get A value. Okay, then what about B? It is not the same, right? 1 plus 3 plus 4 will be again, we are getting 8. That's fine. Okay, what about remaining? C and D? C and D will be eliminated. Why? Because minus 5, 1, 2, 1, 2, right? Sum of the C, illogical. Minus 5, minus 2, yes. C and D will be eliminated. Only one option is there, only two options are there. Either A or B. But how to filter it? Of course, this is first condition. Sum of the roots of a cubic equation should be equated to the sum of the principal diagonals of a given matrix. That is condition number 1. According to this, I can eliminate two options. We'll have two more options. So what happily you can find one more condition. What is that? This is sum of the roots. We'll have one more. What is that? Lambda 1. Product of roots. Very important. Lambda 1 into lambda 2 into lambda 3 should be equated to det A. That's it. Det A. Det A is nothing but what? We need to find the determinant value for the given matrix. Simple, right? That's why this is the best way actually. Don't go for the general calculations now. You have two procedures. Don't confuse. First one is the best one. But after that, okay, if it is 4 marks question or 5 marks question, I believe you can do in that way. But only 1 or 2 marks story, right? That's why don't confuse. Okay? All of you. Okay, according to this one, we'll have two options, either A or B. Right? Now I need to find det value. That's it. So according to the given situation or question, directly you can go for det. That's it. According to det, you can get the answer for sure. Yes, how to find det value for this all? Already we have an idea. Close to direct step, don't confuse. Close to. So 2 should be taken, don't worry. I'm going to find det A value. I'm going to find det A value, don't confuse. According to this, we can eliminate. Okay, according to options, if I go for lambda 1 into lambda 2 into lambda 3, so 1 into 2 into 5 will be, 1 into 2 into 5 will be 10. Option A, we are getting det A value is what? 10. According to given options I'm saying. Then what about B? Option B can be, det A can be, there is a chance, det A can be 1 into 3 into 4, 1 into 3 into 4, so 1 into 3 into 4, 1 into 3 into 4, 12, maybe 12, there is a chance. So logically, option A, det value should be 10, option B, det value should be 12. Which one it is matching? That's the main issue, right? Yes, which one is matching is my perception. So we need not to go for the options directly, for your comfort. Go for the determinant value, 2 into, eliminate row and column, 4 2 is 8, 8 minus 1, directly, 8 minus 1, 8 minus 1, 7, that's it, 2 into 7, first step. But second element, we need to take minus value, minus 1 into, eliminate the entire column and row, 1 into 2, 2 minus 1, 1, that's it. Okay, then what about, very simple story, don't confuse. 1 should be eliminated, 1 column and row should be eliminated, 1 into 1, 1 into 4, yes, 1 minus 4 we are getting, 1 minus 4. 1 minus 4 means minus 3, right? Plus 1 into, eliminate this one, 1 into minus 4, minus 3 will be there, minus 3, right? 2 7s are 14, we are getting 2 7s are 14 positive, minus 1, minus 4 is there, minus 1, minus 4, logically I am getting 14 minus 4, answer is 10, yes, that value is what, 10, that's why option A is correct. The product of roots should be equated to the det value, det of the given matrix. Option is the best option. Option B is not correct. Why? Because product of all the roots we are getting 12, right? But det value is what, 10. That's why it is eliminated. Answer is A. This is the best one, right? That's my perception. Condition number 1. Sum of all the roots should be equated to sum of all the diagonal elements of a given matrix. Product of the roots should be equated to det value. That's it. Nothing is there. Make it simple. Don't make it as complicated. Okay. What is the first procedure? Det of A minus lambda I is equal to 0. What is second method? Remember, lambda cube minus lambda square into sum of principal diagonal elements plus lambda square lambda into so minus of diagonal elements. Finally minus det A is equated to 0. Then we can get directly cubic equation. After getting cubic equation, you can use your scientific calculation. According to that, you can get the roots directly. But before going to the general calculations, we have two ways. What is that? Sum of the roots should be equated to sum of principal diagonal elements. Product of roots should be equated to det A. According to that, you can get the answers. Of course, this is the story of what? Eigenvalues. we'll have one more way. What is that? Eigenvectors. So what? It can be content process. But here what is asking? Eigenvalues only, right? That's when you not worry. I think you got the idea, right? Better to share to your friends and better to log in your website. So after few days, you can realize that we are going to rock or target get 30 marks.